Well, when we bring the sediment samples back to the laboratory, the first place we go is actually right next door. That's like a regular wet chemistry laboratory. We have fume hoods, ovens, and what we're really trying to do is separate out sand-sized grains of quartz and potassium feldspar. Those are the two minerals that are really used in luminescence dating. Once we've purified those, we bring them into this laboratory, which is where all the equipment is stored. And what we now want to do is load them up onto a little metal disc. That allows us to put it into the machine, and the machine has three things to it: a photomultiplier tube, a radiation source, and some kind of stimulating light source. It might be light-emitting diodes or lasers. And what we then do is we put those quartz grains and feldspar grains into the machine and shine light on it and see how much light of a different wavelength we get off. We then give it a known dose, spin it around again, and then measure the amount of light we get off for each unit dose. So that gives us a measure of how much dose is stored in the grains when they were buried. And now by measuring the radioactivity in the field, we've got the two things we need to know: how much dose was stored and how much dose it receives every year. So from those two things, we can work out how old the sediment is, how long ago it was buried in the ground, and how old the artifacts and any fossils associated with that sample, how old they are as well. Well, the latest dating results for the hobbits show that it might have survived up until maybe 50,000 years or so ago, 50 to 60,000 years. And the latest set of field samples we collected this field season, we're really trying to nail down when did modern humans first arrive at the site. So we're working on those samples now in the instrument to see if we can really nail the first time the modern humans stepped foot at Leingbourg.